Hello class, we are returning now to complete chapter 5.3. We're going to start back where we left off at multiplying rational numbers. The product of two rational numbers is the product of their numerators divided by the product of their denominators. If a over b and c over d are rational numbers, then a over b times c over d is equivalent to a times c over b times d. So our example says multiply, if possible, reduce the product to its lowest terms. Now, what we can see with this multiplication is that negative 2/3 times negative 9/4 is equal to negative 2 times negative 9 over 3 times 4. So we're basically just multiplying across the top. Let me get my pen back working. We are basically just multiplying across the top and multiplying across the bottom. So negative 2 times 9, 3 times 4. Negative 2 times 9 is positive 18. 3 times 4 is 12. We do have to reduce once we get to a single fraction here. And our reduction here to simplify the lowest terms would be done by pulling out a 6. So basically 18 divided by 6 and 12 divided by 6 leave us with a 3 over 2. This breaks it down into a multiplication 3 times 6 over 2 times 6, where you can see that the 6's cancel themselves out. And you're left with 3 over 2. Or if you wanted to, you could write it as 1 1/2. You can think back to the last lecture where we talked about mixed numbers versus improper fractions. The quotient of two rational numbers is a product of the first number and the reciprocal of the second number. If a over b and c over d are rational numbers and c over d is not 0, then a over b divided by c over d equals a over b times d over c, which is a times d over b times c. We essentially here kept the first term, changed the sign, and flipped the second term. So I've heard this called before keep, change, flip, because you keep the first term, you change the sign from a division to a multiplication, and then you flip the second fraction. So with a division of fractions, you keep, change, flip. Divide if possible and reduce the quotient to its lowest terms. Here we have negative 3/5 divided by 7 over 11. Negative 3 over 5 divided by 7 over 11. If we keep the first term, negative 3/5, change the sign to a multiply, and then flip this second term to 11 over 7, we should be able to just multiply across. So we're looking at 3 times 11 is 33, 5 times 7 is 35, and we keep the sign out front. So change to a multiplication using the reciprocal, multiply across. We have our final answer. We do check to make sure it cannot be reduced. Here it cannot be, so this is indeed our final answer. Let's look at the sum or difference of two rational numbers with identical denominators. Okay, that sum or difference of two rational numbers with identical denominators is the sum or difference of their numerators over the common denominator. So if a over b and c over b are rational numbers, then a over b plus c over b equals a plus c over b. And a over b minus c over b equals a minus c over b. The key here is they have to have the same denominator. you notice they all have a denominator here of b. They have the same common denominator. If they don't have the same common denominator, we have to do something a little different. But first, let's practice with the same common denominator. Let's perform the indicated operations. 3 over 7 plus 2 over 7. For A, if I look at A, 3 over 7 plus 2 over 7, I'm simply adding the numerators because they have the common denominator of 7. 3 plus 2 is simply 5. So my answer here is 5/7. 5/7 is already in lowest terms. So this is my final answer for A. If I look at 11 over 12 minus 5 over 12, they have the common denominator of 12. So I can simply subtract their numerators as indicated. 11 minus 5 is 6. So 11 minus 5 over 12 reduces to 6 over 12. I do have to reduce here because 6 over 12 is not lowest terms. Their greatest common factor is actually 6. So I can cancel the 6's out here and I'm left with 1/2. Some people break them into terms of factors here and cancel the factor out. Some people see that the greatest common factor is 6 and instead do a simple division by 6 of both terms, and that leaves you with 1/2 as well. Either one of those trains of thoughts work. Now let's look at C. See, a little bit more complicated here. I have negative 5 1/4 minus negative 2 3/4. What we have to see here is in order to properly do this, we need to get these mixed fractions into terms of improper fractions. Now we did improper fractions last lecture, so go back and review that concept if necessary. But in order to change negative 5 1/4 to a mixed, from a mixed fraction to an improper fraction, we would do 5 times 4, which is 20, plus 1, which is 21. So it would essentially look like negative 20 plus 1 over 4, which is where we get the 21 over 4 here, keeping the negative out front. I have to also turn negative 2 3/4 into an improper fraction. 4 times 2 is 8. 8 plus 3 over 4 is how we get the 11/4 here. We also have to keep track of our negatives here. So far they haven't changed from the original problem, but I do have a minus a negative situation here, which we know is going to change into a positive. So now I'm looking at negative 21 over 4 plus 11 over 4. This is negative 21 plus 11 all over 4 because they have that common denominator of 4. Negative 21 plus 11 is negative 10 over 4, which I can write, if I reduce it, because they have a common factor of 2. If I reduce it here, that reduces to negative 5 over 2 as an improper fraction, or negative 2 1/2 as a mixed number. If the rational numbers to be added or subtracted have different denominators, we use the least common multiple of their denominators to rewrite the rational numbers. The least common multiple of the denominators is called the least common denominator, or LCD. Here, A over B equals A over B times C over C, which equals A times C over B times C. We will use this principle of multiplication to help us move forward. All we're essentially doing is multiplying by something that essentially equals 1 in order for us to get a common denominator. This example says find the sum. In order to find this sum, we need to find the least common multiple of 4 and 6 so that the denominators will be identical. The least common multiple, or LCM, of 4 and 6 is 12. Hence, 12 is the least common denominator, okay, LCD. So, we need to convert 3 over 4 plus 1 over 6 into having a denominator of 12 on both. In order to do this, in order to make this denominator 12, to get from a 4 to a 12, we multiply by 3. If I multiply the denominator by 3, I must also multiply the numerator by 3, because I'm essentially multiplying by a value of 1, because 3 divided by 3 is 1. 3 times 3 is 9. 4 times 3 is 12. In order to get this 1/6 in terms of a 12 in your denominator, so we'll have a common denominator, I need to get that 6 to be a 12. In order to do that, I need to multiply by 2, because 6 times 2 is 12. What I do to the denominator, I also need to do to the numerator, because this term here essentially equals 1. 1 times 2 is 2. Now I have two fractions with a common denominator that I can combine. 9 plus 2 is 11, and I keep the common denominator of 12, and I'm good to go. So notice we have 12 in the denominator for each number. We add the numerators and put this sum over the least common denominator. If you can reduce, reduce. Here, 11 over 12 cannot be reduced, so we leave it alone. Let's simplify. We have 1/2 raised to the third power minus 1/2 minus 3/4 squared times -4. Now we are going to use PEMDAS, our order of operations here, in order to simplify this. Noticing that we need to do what is in the parentheses first and then handle the exponents. So because the grouping symbols do appear, we perform the operation within the parentheses first. The operation within the parentheses to be performed is this subtraction of these fractions. So we need to do this first because it is inside the parentheses. There's no operation being done to the 1/2 that's inside these parentheses or the -4 inside these parentheses. Parentheses are essentially just placeholders in those locations. So what I really need to do here, and it's done it for you, but it has shown no steps, is I need to do 1/2 minus 3/4, the operation inside that parentheses. They need a common denominator. Here the least common denominator would be a 4, because I can turn that 2 into a 4 and leave that 4 alone. I need to convert 1/2 to a denominator of 4. To do this, I am going to multiply 1/2 times 2 over 2, because 2 times 2 will give me the 4 that I need in my denominator. Let's continue. 2 times 1 is 2. 2 times 2 is 4. This one already has a denominator of 4, so I do not need to adjust it. Now I'm looking at a very simple operation here of 2 minus 3 over 4, which simply gives me -1 over 4, which is how they got the -1/4 in the parentheses here with the simplification. Now, the next thing we're going to do is take care of our exponents, because we've taken care of all operations within the parentheses. Our exponents here tell us that we need, the first one tells us we need to cube our items. 1 cubed is 1. 2 cubed is 8, because that's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So this is how we get the 1 over 8. We also go ahead and square this on the inside. If we square this on the inside, we are essentially multiplying -1/4 times -1/4. A negative times a negative is a positive, which is why our negative on the inside of this parentheses goes away. Our exterior negative stays here. It has not been touched yet. But negative and a negative turn it into a positive. 1 times 1 is 1. 4 times 4 is 16, which is where the 1/16 comes from. And we just bring down this -4 here. Okay. I'm going to erase some of this work so that we can continue with our next set of steps. If you need to pause or go back or follow along with the work a little slower, feel free to repeat any part of the video or pause any part of the pause any part of the video so that you can get caught up. Alright. So, what they've done to get from this step to this step is they have multiplied here, because we don't do our subtraction yet. We do not do our subtraction yet. We do our multiplication. We took care of the exponents. We have to next do the multiplication. The multiplication here is negative 116 times negative 4. Okay? It leaves the negative out front here and keeps the negative here. So essentially what it's doing is 1/16 times negative 4. Now when we multiply numbers, essentially this is negative 4 over 1. All we're doing is negative 4 times 1 and 16 times 1, which gives us a negative 4 over 16. But we have to reduce negative 4 over 16 to its lowest terms. 4 goes into both 16 and 4, so I'm going to use it to get this fraction to its lowest terms, and that's why it reduces to negative 1/4. So now we are looking at negative, or 1/8 minus negative 1/4. 1/8 minus negative 1/4. This minus a negative here turns this into a positive. So I'm really looking at 1/8 plus 1/4. They do need to have a common denominator to be able to add them. That common denominator is going to be the 8. So I'm going to leave the first term alone. I'm going to multiply the second term by 2 over 2. Two times 1 is 2. 4 times 2 is 8. 1/8 plus 2/8 is the same thing as 1 plus 2 over 8, which is how they get the 3/8. If we could reduce at this step, we would, but we cannot. 3 over 8 is in its lowest terms. Let's look at the density of rational numbers. If r and t represent rational numbers with r less than t, then there is a rational number s such that s is between r and t. So r is less than s is less than t. What this means is if you give me two rational numbers, I can find a rational number between those two rational numbers. And between those two rational numbers, I can also find a rational number. Basically meaning there is an infinite amount of rational numbers that can be created. Let's illustrate this density property. We want to find a rational number halfway between 1/2 and 3/4. First, what we will do is add 1/2 and 3/4. In order to do this, we need a common denominator. The common denominator here will be a 4. So in order to convert to this common denominator, I need to multiply 1/2 times 2 over 2. Let me erase that little stray mark that I just wrote here. I need to multiply 1/2 by 2 over 2, which gives me the 2 over 4 here. Then I can add that to the 3 over 4, because they now have the same common denominator. This gives me 5/4. This is not your answer, though. We have to continue working forward. Now, that 5/4 is that 1/2 plus that 3/4. So to find something halfway between those numbers, we will first add those numbers up and then divide by 2. So the division by 2 is our second step. We will divide 5 over 4 by 2. Now, we know how to divide fractions. So essentially what we do is turn this 2 into a fraction by putting it over 1. Now we keep the first term, change the sign, and flip the second term. Essentially we're multiplying by 1/2 now. 5 times 1 is 5, 4 times 2 is 8, and we see that we get an answer here of 5/8. 5/8 is halfway between 1/2 and 3/4. What we can tell now is that 1/2 is less than 5/8 is less than 3/4. And 5/8 is actually the number that sits exactly halfway between 1/2 and 3/4. Let's look at some problem solving with rational numbers. A common application of rational numbers involves preparing food for a different number of servings than what a recipe gives. The amount of each ingredient can be found as follows. The amount of ingredient needed equals the desired serving size divided by the recipe serving size times the ingredient amount in the recipe. So, if we look at this example, it says a chocolate chip recipe for 5 dozen cookies requires 3/4 cup of sugar. If you want to make 8 dozen cookies, how much sugar is needed? Solution. We need to look at the amount of sugar needed. That equals the desired serving size over the recipe serving size times the ingredient amount in this recipe. Now, the desired serving size is 8 dozen cookies. That is directly from the given word problem. But the recipe serving size is only for 5 dozen cookies. We multiply 8 dozen over 5 dozen times the ingredient amount in the recipe. In this case, the ingredient amount is 3/4 cup of sugar. Okay, so the amount of sugar in cups needed is then determined by multiplying the rational numbers 8/5 times 3/4. Because if you notice, that's basically the multiplication we had down here. 8 over 5 times 3 over 4. This is a very simple multiplication because with multiplication of rational numbers and fractions, we just multiply across the top and the bottom. So 8 times 3 and 5 times 4. 8 times 3 is 24. 5 times 4 is 20. We have now 6 over 5, which is our improper fraction. And if you'd like to write it as a mixed number, you could write it as 1 and 1/5. We reduced this to get to this 6 and to get to this 5 by dividing each of these by 4. This will help us put it in the lowest term. So 24 divided by 4 is 6. 20 divided by 4 is 5. That's how we got the 6/5. And then we can convert that into that mixed number 1/5 if necessary. Because a lot of times we don't have 6/5 written on our measuring cup. We have 1 cup and perhaps cups broken down into fifths or fourths or thirds or whatever is necessary for the recipe. I hope you have enjoyed this lecture. We are now completed with chapter 5.3, so you should be able to complete the homework for chapter 5.3. If you have any questions whatsoever, please don't hesitate to reach out to me and ask. Other than that, I hope you have a good rest of your day.